another branch of fluid mechanics called the vorticity dynamics, which is related to the characteristics of vortices and the governing equations for computing the vorticity. Interaction of vortices in a turbulent flow, for example, or laminar flow. Vortex line, which is a line which is tangent to the vorticity, something similar to a straight line, which is tangent to the velocity vector. The vortex line is parallel to the vorticity vector, or parallel to the axis of the vortex. Any vortex has an axis, because when something rotates, it definitely rotates around an axis. That axis is the axis of the vortex. Horseshoe vortices or hairpin vortices, it means there are kinds of vortices which are similar to horseshoe or hairpin. These are important elements of vorticity dynamics in turbulent flow simulation, using larger dissimulations, for example, or studying the transition of flow or instability of flow, and etc. Also, vortices appear in instabilities such as Taylor-Coit instability, which is the instability of flow between two rotating concentric cylinders, or the Kelvin-Helmholtz instability, which is the instability analysis of creation of instabilities along the surface of, for example, of the water in a lake, for example. These are rolled up vortices, Kelvin-Helmholtz vorticities. And also we have a branch of fluid mechanics which is related to the solid mechanics, which is called the Vortex Induced Vibrations, VIV. This is the, as you see from the title, this studies the vibrations which are induced from creation of vortices and von Karman vortex streets behind the wake of bluff bodies. Also, we have two other terms here which are similar to vortex, but they are different. The first one is cycloid, and the other one is helix or spiral. Cycloid is the locus of position of a point on the rotating cylinder without slipping, just rotating, moving with the rotation without slipping. The position of this point on the surface of this cylinder is a cycloid. The other one is helix, or the plural form is helices. And spiral, there are different kinds of spirals in fluid mechanics or in mathematics. For example, logarithmic spirals. Consider that a flow starts to move from left to right, and there is an ink injection at the end of this point, and this point rotates along a circular path, something similar to a spring or a DNA is called the spiral. They are similar to vortex, but they are different. So we are using spiral to design the volutes of turbomachinery pumps, for example, or turbines. And the spiral is a smooth and continuous line in the curve in the space, in three-dimensional space, which with the tangent line make a constant angle with the axis. You see again there is an axis here. The remainder of my talk today, I will classify different vortices in fluid mechanics. From the first viewpoint, we can classify vortices into eddies and vortex, eddies and vortices. And from the second viewpoint, we can classify vortices into rotational vortices, irrotational vortices, and quantum vortices, which appear in superfluids near the in cryogenic applications near the 0 Kelvin.